All right, tech enthusiasts, ever pondered how GPUs evolved from rendering game graphics to powering today's advanced AI systems? Let's delve into this transformation and explore the future of AI agents. The time of GPU computing isn't just coming, it's already thrown a party, invited everyone. A graphics processing unit, GPU, unlike a general-purpose central processing unit, CPU, is optimized for parallel processing. This makes it highly efficient for tasks involving large datasets, like graphics rendering, machine learning, scientific simulations, and cryptocurrency mining. Here's the twist. That humble pixel pusher evolved. It scaled up, mastered parallel computing, and now fuels some of the most advanced AI systems on the planet. From Doom to deep learning, it's been one wild, unexpected ride.
Welcome to AI Joyful Discoveries. In this video, we're strapping you into our time machine, powered, of course, by a bunch of GPUs to trace this crazy journey.
We'll trace the journey from those pixelated origins to today's GPU powerhouses, now building AI agents smart enough to run your life, and maybe even your company. You don't need a computer science degree to follow along. If you've ever appreciated clever tech or chuckled at blocky old graphics, you're more than qualified to be part of this ride. So, where did this adventure begin? Like all great origin stories, it starts with wanting things to look better. Specifically, video games. Back in the ancient times of the late 90s, graphics were, let's just say, charmingly blocky. Characters looked like they were made of Legos, and textures were blurrier than Bigfoot photo. Then, in 1999, NVIDIA dropped a bombshell. The GeForce 256. They didn't just call it a graphics card, they boldly christened it the first GPU, the graphics processing unit. It had dedicated hardware doing the heavy lifting for 3D graphics. And boom! Pixels started getting their act together. Surfaces looked smoother, lighting got fancy, and things started to look, dare I say, real? Those weren't just rejoicing. They were performing interpretive dances of joy. Your video card wasn't just a component, it was your ticket to a prettier, more immersive world. It went from being something only hardcore nerds cared about to being, well, still a little nerdy, but absolutely necessary if you wanted to play the coolest games. At this point, the GPU was like a rock star guitarist who only knew shredding solos for video game soundtrack. Its incredible power was strictly for making virtual stuff look pretty. AI was barely a blip on its radar. But then came the plot twist. Around 2006, NVIDIA introduced something called CUDA. Think of it as a universal translator for GPUs. Before CUDA, they only spoke graphics. With CUDA, they could suddenly understand math, lots of math. Scientists, researchers, and people who really liked complicated spreadsheets looked at these gaming powerhouses and had a collective hold on a minute moment. They realized, wait, these things have thousands of tiny efficient cores. They can do thousands of calculations at the exact same time. This isn't just a pixel painter, it's a super calculator. Suddenly, GPUs weren't confined to just rendering dragons and explosions. They were unleashed. People started using them for serious number crunching, simulating complex weather patterns to predict hurricanes faster, sequencing DNA with unprecedented speed, running intricate physics simulations. Things that used to take supercomputers days or weeks could now be done in hours or minutes. Like finding out your gaming PC could also solve complex scientific puzzles. The GPU transformed from cool gamer gear to vital research rocket fuel. It was flexing its muscles beyond just drawing pretty pictures. And then the AI wave hit hard, especially the rise of deep learning in the early 2010s. Turns out, training these massive neural networks the brains behind modern AI, requires an insatiable hunger for computation. You need to perform trillions, even quadrillions of calculations to teach an AI model something complex, like recognizing a cat in a photo or understanding human language. Traditional CPUs, bless their hearts, they're amazing at sequential tasks, like running your operating system or opening emails. But training deep learning models is like trying to move a mountain of sand one spoonful at a time. CPUs just weren't built for that level of parallel heavy lifting. GPUs? Perfect. They had thousands of those efficient cores, ready to crunch numbers simultaneously. They were like bringing a fleet of bulldozers to that sand mountain. They could handle the sheer volume of matrix multiplications and computations that deep learning demanded. But there's a specific moment, a legendary tale in AI history about how this truly kicked off. Enter the godfather of AI, Geoffrey Hinton, and his brilliant team. They were training a massive neural network to recognize objects in images, a task that would take forever on traditional processors. They were training a massive neural network to recognize objects in images, a task that would take forever on traditional processors. They had a crazy idea. Use gaming GPUs. They hooked up several NVIDIA GPUs, and suddenly training went from agonizingly slow to, well, lightning fast by comparison. This speed allowed them to train a much larger, deeper, more powerful network than anyone thought possible at the time. They entered this network, famously known as AlexNet, into the prestigious ImageNet competition in 2012. And they didn't just win, they absolutely dominated, slashing the error rate and blowing everyone else away. It was a mic drop moment heard around the world. That victory wasn't just about winning a contest, it was irrefutable proof that deep learning, when powered by GPUs, was the future. This moment ignited the modern AI explosion we see today. Suddenly, NVIDIA wasn't just selling chips to gamers and scientists, they were the absolute essential engine powering the AI revolution. Every major tech company, every research lab pushing the boundaries of AI needed GPUs, from image recognition that helps your phone sort photos to the early large language models that would eventually become things like ChatGPT. GPUs were the workhorses making it all possible. Fast forward to literally right now, we're not just buying GPUs anymore, we're building AI factories. NVIDIA isn't just a chip company, they're creating entire platforms. We're talking massive clusters of GPUs working together like a futuristic assembly line. Specialized silicon designed specifically for AI like their Grace Hopper chips. And software platforms like Omniverse that let you build complex digital twins and simulations. This isn't just about training the next big AI model. It's about deploying AI into everything. Industries are using these AI factories to build smarter robots that can navigate and interact with the physical world. Create incredibly detailed digital twins of factories, cities, or even the entire planet to simulate scenarios. Develop advanced autonomous systems. And yes, create the next generation of AI agents. If the early 2000s were about the rise of the GPU, the 2020s are undeniably the era of the AI supercomputer, where this technology is being industrialized. And the cool part? While the underlying tech is complex, the applications are becoming so integrated that you don't need to be a programmer to interact with or benefit from it. And want a glimpse into where this is all headed? Keep an eye on NVIDIA GTC Paris. If GTC 2025 in San Jose gave us a taste of physical AI and robotics, Paris is set to take it even further. And now, the absolute cutting edge of AI factories and AI agents converging So, fueled by all this incredible power we've discussed, where is this rocket ship headed next? NVIDIA has a vision centered around building the next generation of intelligent systems, AI agents. These are the future. Forget simple chatbots that just follow scripts. AI agents are designed to be sophisticated digital workers that can reason, make independent decisions based on data and goals, communicate, and even learn. Building these complex agents isn't like whipping up a simple program. It requires integrating serious computational power with advanced software and models. And this is where NVIDIA's AIQ framework or foundation blueprint, choose what sounds best, comes in. Think of AIQ as NVIDIA's expert guide, a technical reference for building those cutting-edge AI agent systems we mentioned. It brings together their accelerated computing software and models like Nemotron, providing the foundation for enterprises to build digital workforces capable of handling complex tasks with high accuracy and speed. It's not just about having AI, it's about using this blueprint to build systems that make you smart at using AI. Imagine a digital assistant that doesn't just tell you the weather, but analyzes your calendar, traffic data, and your past preferences to suggest the optimal time to leave for your appointment. Or an agent that manages your inventory, predicts demand, and automatically places orders. It's like having a super competent, tireless digital employee powered by GPUs. From games to genius, the GPU computing era hasn't just arrived. It's accelerating faster than ever. Whether you're playing a game with stunning graphics, asking an AI for recommendations, or seeing automation in action, you are absolutely riding the GPU wave. So there you have it, the incredible, slightly bonkers journey of the GPU, from making Lara Croft look slightly less pointy to powering the brains of future digital workers built with advanced toolkits and frameworks like NVIDIA's AIQ. It's a story of unexpected evolution and exponential growth. Don't forget to smash that like button if you enjoyed this ride. Hit subscribe to join our crew for more tech adventures, and let us know in the comments. What's the craziest thing you think an AI agent could do in the future? Thanks for watching, and we'll see you in the next discovery.